In this video, we're going to discuss properties of the right-angled triangles. So I have one here, and I've dropped the altitude in the triangle. And I'm going to call this side A. This is B. The altitude is H. The small segments here are X and Y. And the large side has length C. First of all, let's look at the angles. We know that if this is alpha, then this is 90 minus alpha. And so this is alpha, and this is 90 minus alpha. And therefore, we have three similar triangles on this picture. This triangle is similar to this triangle, is similar to this triangle. And we can get some useful relations out of these similar triangles. For example, using that this triangle is similar to this triangle, then x divided by h equals h divided by y, because these are the corresponding sides in the similar triangles. And from this we get that h squared equals x times y, as written here. Next, if we consider this triangle similar to the large triangle, we get that b divided by x equals c divided by b, because these are the corresponding sides in the two triangles. And so we get that b squared equals x times c, as written here. And similarly, a squared equals y times c. And now that we get these two equalities, we can add them together and get that a squared plus b squared equals c times x plus y from here. But now x plus y, on the picture you can see it equals c. And so a squared plus b squared equals c squared, which is the Pythagorean theorem. Importantly, every time we have a picture like this, in which we have x, y, and h and a right angle here, such that h squared equals xy, then we can conclude that this angle here between the red dashed lines is 90 degrees, because we can prove it by considering this triangle is similar to this triangle, and therefore this angle plus this angle must be 90 degrees. Also, if we have a picture like that, in which we know that this is b, this is x, and this here is c, and we know that b squared equals xc, then we can conclude that this angle here is 90 degrees. Again, by considering the similarity of this triangle and this triangle. Or by just using the fact that if we consider the power of this point with respect to the circumcircle of this triangle, on the one hand it is x times c, on the other hand it is b squared because of the relation here, and therefore this line must be tangent to the circle around these 3 points. And so the only way it could be tangent is if this is 90 degrees, because the center of the circle around this triangle is the midpoint of this side, because this is a 90 degrees after all. This is the optional problem. We have a triangle, and the three altitudes in the triangle are drawn. The circle with diameter this side intersects this altitude at this point, and the circle with diameter this side intersects this altitude at this point. We have to prove that this length equals this length. And here's the solution. We know that this point and this point lie on the circle with diameter this side, because of the 90-degree angles here and here. Similarly, we know that this point and this point lie on the circle with diameter this side, because of the right angles here and here. Furthermore, for this point, we know that this angle is 90 degrees because this is a diameter. And similarly for this point, we know that this angle is 90 degrees because this is a diameter. Now consider this triangle here. It's a right-angled triangle, and this is an altitude in the triangle. And therefore, this length squared equals this length times this length. I'm going to mark the sides x and y, the ones we have to prove are equal. This is d, the large side is c, this small segment is e, and the large side here is a. And so we found that x squared equals d times c. Similarly, from this right-angled triangle with an altitude here, we have that y squared equals e times a. Now, since we want to show that x equals y, then the only thing left to prove is that dc equals ea. But this is true when we consider the power of this point with respect to the circle with diameter this side of the triangle, because this point and this point lie on this circle with diameter this side because of this right angle and this right angle. So the power of this point with respect to the green circle on the one hand is d times c, and on the other hand is e times a. And therefore d times c equals e times a. And finally, this means that x equals y.